These scenes were filmed almost 100 years ago. Einstein, with his wife, arrives in the United States, where they are met by a throng of journalists from all the leading American media. The scientist's visit is a super event. By that time, Einstein had already ceased to be just a scientist. He had become a celebrity. In the following century, everyone would know that he had a high IQ, disheveled hair, and informal manners, that it was he who formulated the theory of relativity and had a hand in the creation of the atomic bomb. And while the degree of Einstein's popularity raises no questions with anyone, the extent of his contribution to science has been questioned by renowned scientists and anonymous internet users alike. The claims are as follows. Young Albert was poor in mathematics, and he did not enter university on his first try. The idea that everything is relative is more of a philosophical notion than a physical one, and is generally an idea obvious to a fifth grader. And the fact that Einstein's portrait can still be seen everywhere rather proves that his figure was artificially inflated. After all, Newton essentially created classical physics, but his image is not printed on t-shirts. Well, this is going to be a long, interesting video. Myths will be debunked, doubts dispelled, and questions answered. What can be said right now is that Albert Einstein was a contradictory figure. A scientist who believed in God, a pacifist who contributed to the atomic bomb, a physicist who preferred fantasies to equations, and finally a man who challenged the universe. The main problem regarding Einstein's figure, whether he was a genius or not, and whether he advanced science or hindered it, is as follows. Approximately 100 years ago, science began to develop so rapidly that it became incomprehensible to the ordinary man. From Newton's time until roughly the end of the 19th century, a person with a good basic education was more or less aware of what was happening in contemporary physics, chemistry, and astronomy. At the beginning of the 20th century, science started moving too fast, making it difficult to determine whether Einstein was a genius or a hyped charlatan. Yet difficult does not mean impossible. And of course, physics is far from the only topic I will discuss. Einstein witnessed 2 world wars, led a vibrant personal life, and could quite possibly have become the hero of a reality show if there had been such a possibility at the time. Consider this video a brief guide on how to become the most famous scientist in human history. Einstein was not born Einstein. In early childhood, the boy's parents did not suspect that a future genius was growing in the family. Quite the opposite. The boy struggled to learn to speak. Concerned parents even consulted a doctor. They feared that Albert might never master speech. The maid called the child slow-witted, and I suppose in German this description sounded even harsher. Gradually, the boy learned to speak, although he did so later than his peers, and for many years before saying something out loud, he would mutter a phrase to himself. However, this shortcoming may have transformed into Einstein's super ability. Firstly, he thought not in words, but in images. This trait would later become the foundation of his scientific method. Secondly, from childhood, Albert posed unexpected questions that seemed obvious and clear to everyone around him. Both of Einstein's parents were descendants of Jewish merchants who had lived in southern Germany for several centuries. This period was quite sufficient for them to consider themselves more German than Jewish. However, it was precisely his nationality that prevented Albert's father, Hermann Einstein, from obtaining a higher education. He spent his life in entrepreneurship. Not too successfully, as he was a gentle person and therefore the family was not wealthy. The future scientist's mother, on the contrary, possessed a strong-willed character and the ability to sharply tease an interlocutor, a trait that undoubtedly passed on to her son and caused him quite a few problems in adulthood. Initially, his parents wanted to name their firstborn Abraham, but later decided to change it to something less Jewish. Thus, in the year 1879, Albert Einstein was born. A modest and unsociable child, this is how those who remembered his childhood years described the future genius. Albert's parents were such non-religious Jews that they initially sent the boy to a Catholic school simply because it was closer to home. This is especially amusing, given the fact that Albert Einstein would nearly become the President of Israel. But more on that later. At this moment, we are interested in another fact about the genius's school years. On dozens, if not hundreds of websites, one can find the following claim that Einstein failed mathematics in school. The last hope for those who also struggled with sines, cosines, and logarithms. And alas, folks, this is a myth. In reality, it was quite the opposite. Einstein's secondary school had a focus on mathematics, and even there he was significantly better than his classmates in this subject. In short, where this myth originated from is not entirely clear. Einstein himself frequently laughed at it and said that by the age of 15, he already knew what differential and integral calculus were. It was in secondary school that Albert's character began to show signs of free thinking and a rejection of authorities. This often led to his conflicts with teachers. After one such incident, a teacher told Einstein that nothing worthwhile would come of him. In the mid-1890s, Hermann Einstein's company went bankrupt. He was involved in the electrification of cities and, not receiving another government contract, decided to move with his family to Italy. There, in his opinion, the competition was lower. 16-year-old Albert was left with acquaintances in Munich. He had 1 year left before finishing school. But Einstein would not be Einstein if he hadn't quarrelled with the teachers and left to join his parents in Italy 6 months before graduation. Perhaps the reason was the large amount of rote learning. Einstein hated this with all his heart. Perhaps the reason was the German inclination for system and order, which also contradicted Albert's character. Or perhaps the reason was Einstein's unwillingness to join the army at the age of 17. This was mandated by German legislation. It is hard to imagine two things more distant from one another than Albert Einstein and military service. A few years after obtaining Swiss citizenship, he would eventually have to serve, but he was declared unfit due to flat feet and excessive sweating of the feet. However, Einstein's aversion to military service was far from physical, but deeply mental. We will return to this point several times throughout the video. For now, let's focus on the fact that Einstein fled to Italy and prepared independently to enter university. At that time, the Zurich Polytechnic in Switzerland was not the best university in Europe, not the best university in Switzerland, and not even the best university in Zurich. And Albert Einstein was unable to gain admission. Opponents of Einstein could certainly use this fact to their advantage, but that is far from the whole truth. Firstly, Albert failed the entrance exams in the humanities, notably in languages. He passed the exams in mathematics and other exact sciences more than successfully. Secondly, Einstein was admitted to the university on his second attempt. Thirdly, the Zurich Polytechnic was nevertheless a very reputable educational institution, and gaining admission was not easy. In the year 1896, Einstein began his studies at the university. By that time, Albert was already a person without citizenship. He had renounced his German citizenship due to his rejection of Prussian values, and it would be several years before he obtained a Swiss passport. Throughout this time, Einstein lived and studied peacefully, essentially being a stateless person. One of the many famous quotes of the notable scientist was the following: "Blind respect for authority is the greatest enemy of truth." He altered this principle towards the end of his life, but during his studies at the Polytechnic, he adhered to it 120%. Professor Weber taught physics at the Zurich Polytechnic. Young student Einstein enjoyed his lectures and initially did not even miss them. However, over time it became apparent that Weber's course did not cover relatively recent discoveries, notably Maxwell's equations. These very equations describe the speed of light and the fact that its speed is always constant, approximately 300,000 kilometers per second. Einstein had studied Maxwell's works back in school, and they troubled him. He would visualize and ponder. What if one could travel alongside a light wave at 300,000 kilometers per second? Would it then appear to be motionless? It is unsurprising that the absence of such an important element in the university course caused sharp incomprehension on the part of the future genius. Tensions with the instructor escalated. It reached the point where the young student began familiarly calling the instructor Mr. Weber, instead of the respectful Mr. Professor. One day, following yet another argument, Mr. Weber gave Einstein a failing grade, which was doubly insulting, considering the university's grading scale was out of 6. Another serious conflict for the future genius occurred with a mathematics instructor. The reason was simple. Professor of Mathematics Minkowski did not observe student Einstein at many of his lectures. Einstein skipped them and later copied the notes from a friend. For this, Professor Minkowski nicknamed Albert a lazy dog. Einstein's specialty was theoretical physics. In the 1990s of the 19th century, the discipline was just beginning to become an independent science. The fact that Albert was precisely a theoretician was proven by his failures in the laboratory. During one of the experiments, the equipment exploded and Einstein was seriously injured. The experiments that truly succeeded for Einstein took place inside his skull. There, he could painlessly navigate the cosmic space, stand in an elevator cabin, and rush on a train at the speed of light. These visual experiments would lead to the emergence of the theory of relativity and other breakthroughs of the genius, but that would happen later. In the year 1900, despite absences and conflicts with professors, Einstein graduated successfully from the Zurich Polytechnic, with an average grade of 5.7 out of 6 possible. He received a diploma and could claim a position as an assistant professor at a university. Einstein sent resumes across Europe. A minority of letters contained rejections, the majority remained unanswered. Some resumes Albert sent twice, but still to no avail. Most likely his personality was the main reason. For instance, he might send a critique of a professor's scientific works as a resume to the professor from whom he was seeking a job. The idea, of course, was questionable. Furthermore, the young graduate was convinced that his former teachers from the Polytechnic were plotting against him by giving bad recommendations. Considering Albert's character, this is not surprising. Einstein's emotional intelligence was clearly not at its peak. After a year of unsuccessful job searching, he was discouraged. Rare gigs like private lessons barely allowed him to make ends meet. There are moments when a seemingly insignificant life choice by an individual can change the course of history. In the early 20th century, such a choice was made by Albert Einstein. He could have abandoned science and gone to work as an engineer in his father's company in Italian Milan. Einstein would undoubtedly have become a good engineer, not a genius but quite decent. But he chose science. Another year passed, and an Albert's university friend helped him find a job at the patent office in Swiss Bern. The position of third-class expert was the lowest. To qualify for something more, one needed to defend a degree. But several of Einstein's applications for a doctorate were rejected by the Zurich Polytechnic, and it might seem that the low position in the patent office should have upset the recent graduate eager to study science. However, Einstein himself was pleased with such an offer. The job search had worn him down in vain, and besides, the salary of a lower-class clerk was significantly higher than that of an assistant professor. But most importantly, Einstein could continue writing his scientific works in his free time, and sometimes even in the middle of the working day. Moreover, he could do this truly freely, without regard to the conservative scientific community he would have had to consider if he were an assistant at a university. He worked at the patent office for 7 years, 8 hours a day, 6 days a week, and those very 7 years became the most productive in his creative journey. All the most significant discoveries of the genius were made precisely then. So, a 5-day work week in an office is not a verdict, but merely an excuse. In the year 1905, the young patent expert sent a letter to his friend Conrad. No one could have anticipated that these few pages written in a free manner would become one of the most important documents not only in the history of physics, but in science in general. Einstein calls his friend a frozen whale, reproaches him for leaving, and then throws in a few thoughts he is working on. Imagine, in general, that a friend writes you a message and 10 years later receives a Nobel Prize for that message. The situation with Einstein's letter looked somewhat like that. So what was so remarkable in this letter? On the first page was the theory of quanta, stating that light is not a continuous wave, as was previously thought, but also a stream of small particles called quanta. For those far removed from physics, this might not sound very impressive, but in reality, this discovery changed scientists' understanding of the universe, and it was for this that Einstein eventually received the Nobel Prize, not for the theory of relativity. On the second page was a work on determining the true sizes of atoms. To give you an understanding, at that time, not all scientists even acknowledged the mere existence of atoms. On the third page was a work on the analysis of the movement of microscopic particles in a liquid. On the fourth page was a draft of a work on the electrodynamics of moving bodies, which would eventually become the special theory of relativity and revise Newtonian views on space and time. And this very fourth work would later lead to the emergence of the most famous equation in the history of physics, the equivalence of energy and mass, multiplied by the speed of light squared. I'm sure not everyone grasped the idea in terms that I listed, don't worry. Firstly, at the beginning of the 20th century, not all eminent scientists understood what it was about. Secondly, a little later, I will explain in simple terms what it's all about. All you need to know now is that the year 1905 was special. 365 days in the life of a genius, which will later be called the Annus Mirabilis. In just 1 year, Einstein published in a scientific journal 4 articles from the letter to Conrad. These theories would later turn the scientific world upside down and secure Einstein the title of a genius. But if you think that after publishing revolutionary articles, Einstein was immediately offered a professorship, invited to the Academy of Sciences, or given some award, you'd be mistaken. Recognition would not come immediately. He would continue to work at the patent office for another 4 years. His personal life at that time was no less eventful than his scientific one. The truth is, it was difficult to determine where one began and the other ended. By the age of 26, Einstein had already managed to get married and become a father twice. His wife, Mileva Maric, she was not just a wife, but also a partner in his scientific work. They studied together at the Zurich Polytechnic. For Albert, attending university was a good achievement, but for Mileva it was a true accomplishment. Mileva Maric grew up in Serbia, and her love for mathematics and physics was evident from an early age. Since then, Mileva began her arduous journey in the harsh male-dominated world of the exact sciences. The girl's parents were not related to science. Mileva changed several schools, each time moving to a more advanced one, and finally ended up in the male grammar school in Zagreb. Moreover, she was the best student and the only girl. Due to an illness she suffered in childhood, Mileva Maric walked with a limp, and few considered her beautiful, at least in any conventional sense of the word. Her romance with Einstein during the second year at the Polytechnic came as a great surprise to both Albert's friends and his parents. At that time, he was already in a relationship. Many of Albert's relatives considered the kind and sweet girl Mari from a Swiss family known to Einstein to be his future wife. Mari herself thought so too. But Einstein was studying in Zurich, and she lived in another city, and apparently long-distance relationships didn't work even 100 years ago. For Einstein, Mileva Maric was the perfect girl. Firstly, he did not share the opinions of those around him and considered her super attractive. Their personal correspondence from that period contains many unambiguous hints. For example, Einstein wrote to her, "We understand the dark sides of our souls so well, and it is so good to eat sausages together, drink coffee and other things." The second reason for their passionate romance was their shared passion for science. In correspondence and personal meetings, they argued and discussed physics. The parents of both were against their relationship, let alone marriage. But despite this, a year after Einstein graduated from university, Mileva became pregnant. At that time, she was preparing to retake her exams since she had failed them the first time and could not graduate from the Polytechnic with Albert. At that moment they were living together and Einstein was unsuccessfully looking for a job. Mileva failed her exams again, and in the last months of her pregnancy, she left for her parents in Serbia. Her academic career was over. The mystery of Albert Einstein's first child remains unsolved to this day. The very existence of the first daughter became known relatively recently. In Serbia, Mileva gave birth to a girl. Most likely she died at a very young age from scarlet fever. The second version is that Mileva gave the child up for adoption and went to her husband in Zurich. In any case, Albert Einstein was not present at the birth and most likely never saw his first daughter in his lifetime. Einstein was a theoretical physicist, and the episode with his first child and subsequent relationships with his two sons suggest that his love for them was also theoretical. Humanity interested Albert much more than individual people, even those closest to him. In the same year, 1902, Albert's father passed away. On his deathbed, he gave his approval for the marriage to marriage. A year later, Albert and Mileva modestly married in the company of a few friends. Another year later, their son Hans was born. It was then that Einstein's marriage began to unravel. However, several years would pass until the separation and decades until the official divorce. Mileva Maric still lived for science. She wanted to be an equal partner in her husband's work. They would discuss his ideas together at night, perform calculations, and develop hypotheses. But after their son was born, Albert expected Mileva to take on the primary care of the child. Maric had different views. A particularly striking episode was the publication of Einstein's scientific papers in 1905. At the end, he mentioned his university friend who had helped him with the work, but he did not mention Mileva. Naturally, she was deeply hurt by this. Whether this was justified is another question. Yes, she assisted Einstein primarily by performing mathematical calculations for his physical theories. On one hand, objectively speaking, this was not a full contribution to the scientific works, not adding anything new to the theories. On the other hand, all those years Einstein shared his ideas with Maric. She supported him, and considering Mileva's biography, one can understand her feelings. Her husband was living her professional dream while she was washing diapers. In 1910, the couple had a second son, Eduard. However, this not only did not save the marriage, but rather the opposite. By that time, Albert Einstein was finally recognized by the scientific community. What exactly his contribution was, we will discuss very soon. Einstein was offered a position at the Academy of Sciences in Germany and a professorship at the University of Berlin. Mileva Maric was prone to depression, with a family history of schizophrenia, which would later affect their second son, Eduard. The relationship between Mileva and Albert deteriorated further, and Mileva's career was certainly over. Einstein increasingly buried himself in work, finding refuge there from all life's troubles. Finally, Mileva learned of her husband's affair. His lover was Elsa Lowenthal, who was also a relative of Albert. Not a close one, but a relative nonetheless. Elsa's father was a cousin of Einstein's father. Elsa Lowenthal was a divorced mother of 2 children. She was the same age as Mileva Maric, and perhaps that was the only thing that united these 2 women. Elsa had no knowledge of physics. However, her true strengths were warmth and care. This is precisely what Albert Einstein sought during the collapse of his marriage. By 1914, Mileva Maric was aware of her husband's affair. Einstein was also aware of Mileva's affair on the side, but neither was ready for a final divorce. Einstein proposed a compromise to Mileva, a strict contract which essentially turned their marriage into a mere facade with the possibility of communicating with their children. According to the terms of the contract, for example, Maric was obliged to perform all household chores, leave the room at her husband's first request, and of course the contract prohibited any intimate relations. Initially, Maric accepted the contract, but after a couple of months she took the children and left for Zurich. A close friend of Einstein later said that on that day, it was almost the only time in his life that he saw Albert in tears. The official divorce would only occur 5 years later. Einstein, understanding he was dealing with a woman knowledgeable in science, offered her a unique deal: divorce in exchange for the Nobel Prize. By the time of the agreement, Albert did not have it yet, but he was convinced he would receive it in the coming years. The prize came with a substantial financial reward which Albert would give to Mileva. Maric, fully aware of the significance of her husband's discovery, agreed. In the year 1922, he would receive the Nobel. With that money, Mileva bought several buildings in the centre of Zurich. And now, it's time to return once more to the year 1905, to those few scientific papers by Einstein that revolutionized the history of physics and our understanding of the universe. The ideas expressed in them were so revolutionary that some renowned physicists of the time did not accept them. Others could not believe that their author was a young clerk from the Patent Bureau. I'll try to explain as simply as possible. Let's start with the general context. The very beginning of the 20th century. Science had gained incredible momentum. People of that time felt they were living on the cutting edge of scientific knowledge, and indeed they were. The famous physicist Kelvin said the following: "There was nothing new left to discover in physics, only more precise measurements remained to be conducted." Of course, he was categorically wrong, but undoubtedly sincerely mistaken. In the 17th century, Newton derived laws that described the universe in an entirely mechanistic way. A falling apple from a tree conforms to the same laws as the moon orbiting the Earth. Gravity, mass, force act on objects, and cause leads to effect. Those are the very formulaic concepts we learned in school. Put simply, it was an analog representation of the universe. In the mid-19th century, physicist Faraday supplemented Newton's ideas with the discovery of electrical and magnetic fields. An electric current creates a magnetic field, and a changing magnetic field can create an electric current. Soon after, Maxwell, in his famous equations, described how electric fields give rise to magnetic ones. In short, these very fields were the supernew that Newton did not anticipate. If you didn't understand anything, that's okay. The most important thing is this: Newtonian classical physics and the new discoveries of Faraday and Maxwell did not synchronize with each other at all. Maxwell and other scientists were confident that marrying these two different physics could be achieved with the so-called ether. It was a super popular theory of that time. Simply put, this is an invisible substance that fills the universe and through which light waves can also pass. It's like water for waves in the sea or air for sound waves. By the way, the expression live broadcast originates from this concept of ether. And it seemed all was fine, Newtonian physics, Maxwell's physics, and the same ether. However, in the early 20th century, it turned out that there was no ether, and no one understood what to do next. We will focus on two of Einstein's most significant discoveries. The first is light quanta. It was precisely for this that Einstein eventually received his only Nobel Prize. For a long time, it was believed that light consisted of continuous waves. Max Planck, a physicist and possibly the foremost scientist in the world at that time, while performing calculations related to radiation, derived an equation known even to those who are far removed from the exact sciences: Planck's constant. No one at the end of the 19th century understood what Planck's constant was. Even Planck himself didn't quite comprehend it. From the equation, it seemed to follow that light was not only a wave, but also particles. Planck was convinced that this was merely a mathematical trick, unrelated to physical light. Meanwhile, a low-grade clerk in his spare time managed to prove that light indeed consists of particles. Their name is quanta. From this would later emerge quantum mechanics and the entire field of quantum physics. And while not everyone knows about light quanta, even children have heard about the theory of relativity. Those critics of Einstein who presume that the theory of relativity is mere philosophical thought not only lack understanding of physics, but also entirely fail to delve into it. Warning, it's about to get complicated. But to understand Einstein's personality, one cannot overlook his greatest creation. As you have understood, for several centuries, Newton's theories dominated physics. They described our world simply and comprehensibly. There is the concept of space. It's like a big stage. The stage is filled with matter, existing separately from the stage. Somewhere aside, time flows uniformly for everyone, without interacting with space and matter. However, today, even a schoolchild understands that something is off with this worldview. After all, from space movies, everyone knows that time flows differently there. And a person being outside the planet will age slower than other inhabitants of Earth. We know this thanks to Einstein and the theory of relativity, which fundamentally changed everything, and here's how it happened. The Swiss are good at several things: banks, chocolates, and clocks. While working as an expert in the patent office in Bern, Einstein often examined applications for inventions that synchronized clocks in different locations. At that time, a simple question arose in his mind. What does simultaneous mean? The answer seems obvious. It is an event occurring at the same time. For this, Einstein presents a visual experiment as an example. As you recall, this is his strong point, so imagine this. A man is standing on the platform at a station. At that moment, in the distance, lightning flashes on both the right and left sides of the man. Both lightning strikes are equidistant from the man. Thus, the light from both lightning strikes reaches him simultaneously, and he can state that the lightning strikes occurred simultaneously. Now imagine that at the exact same moment, a train rushes past the platform at high speed, with a woman standing in the middle of this train. At the moment the lightning strikes occur, she is precisely in the middle of the platform's length. For her, the lightning strike will not seem simultaneous, as the train is in rapid motion, meaning the light from the lightning in the direction she is moving will reach her faster, and it will seem to her that this lightning struck first. At the same time, the man standing still on the platform will continue to be convinced that the lightning strikes were simultaneous. From this, Einstein draws the conclusion: the concept of simultaneity is relative. It is relative to whether you are at rest or in motion, therefore time itself is relative. For a person in motion, time flows more slowly than for a person who's at rest. In a word, if you spend your whole life flying in an airplane, you will age slightly slower than your twin brother on the ground. However, considering that you would have been sitting all this time, your health wouldn't be that good. In short, everything is relative. Okay, I understand that the theory of relativity is not easy, and if you didn't understand, don't be embarrassed. Remember that even the best physicists of the early 20th century didn't understand it either. It's no coincidence that immediately after the publication of this scientific work, no one rushed to bombard Einstein with job offers at universities. Yes, it would take several years for the scientific community to comprehend the ideas. Even Einstein himself didn't finish his work on the theory of relativity in 1905. What I described came to be known as the special theory of relativity. It was called special because it could only be applied to a specific case, namely to objects moving at a constant speed. Einstein, however, wanted to create a theory that could be applied to the entirety of physics. Therefore, he spent another 10 years working on what would be called the general theory of relativity. The revolutionary discoveries did not stop there. The last complex matter we will discuss is gravity. Since Newton's time, everyone was aware of how it worked. However, even here, Einstein found a discrepancy. And he did this primarily not with equations, but using a thought experiment. Imagine you are inside an elevator cabin, standing on the ground. Your feet will be pressed firmly to the floor. An apple that falls from your hands will inevitably hit the floor. Now imagine that you are in the same cabin, but it is flying upwards in space at high speed. Your feet will be pressed to the floor, and an apple released from your hands will also fall to the floor. There is no gravity in space. What is happening then? This visual experiment pushed Einstein to one of the key aspects of the theory of relativity. The gravitational and inertial mass of any object are equal. In the next step, Einstein turned our understanding of gravity on its head. How did he achieve this? With a visual experiment, of course. Imagine a stretched fabric. If you place a large heavy ball in the middle, the fabric will bend under its weight. If you then place several small balls on the surface of the fabric, they will roll towards the heavier one. The same thing happens with planets, only instead of a two-dimensional fabric, we have a three-dimensional universe. A large planet seems to bend space, and smaller planets are attracted towards it. This explained how, for example, the Sun keeps the Earth in its orbit. All these thought experiments and calculations led to the emergence of the most famous equation in the history of physics: the equivalence of energy and mass multiplied by the speed of light squared. I am sure that professional physicists are already starting to write angry comments under the video with corrections and inaccuracies that I have made. Viewers who are far from exact sciences, I hope, were able to roughly understand the essence of Einstein's work, and primarily the theory of relativity. During the 20th century, the theory of relativity would be accepted by all scientists and used in their work. Thus, Einstein's contribution to science is truly immense, and this became possible thanks to his extraordinary ability to visualize images and question even the established truths of great authorities. All of this explains Einstein's right to the Nobel Prize, his honorary place in the history of science. But what remains unclear is how he managed to become the most famous scientist in history and a true celebrity on par with the major stars of show business in the first half of the 20th century. We will discuss Einstein as a superstar further. The key to the success of a bright protagonist in film and literature is always a strong antagonist. In Einstein's case, such an opponent was anti-Semites around the world and primarily in Germany. As you remember, Albert's parents were not at all religious, and he shared his parents' sentiments for a long time. But the First World War changed a lot. In 1914, Einstein became the only scientist from the Prussian Academy of Sciences who did not support Germany's invasion of an independent country. I think it is needless to say how brave a step this was. When the war ended, Einstein was almost 40 years old. In defeated Germany, they immediately began to look for perpetrators of the defeat within the country. Jews became the ideal candidates for the role of the enemy. Growing anti-Semitism was expressed not only at the everyday level, but also reflected even in the exact sciences, for example, physics. Among the esteemed German scientists, there emerged those who believed that Germany needed its own foundational physics, a science that would be built solely on solid physical evidence, and that theoretical physics, primarily the theory of relativity, also known as relativistic theory, were all the contrivances of Jews. By that time, Einstein was not only a member of the German Academy of Sciences, not only a professor at Berlin University, but he had also regained German citizenship in addition to his Swiss citizenship. For Einstein, anti-Semitism led to interesting results both in scientific and social life. To ensure that his theories of relativity were not accused of falsehood, experimental proof was necessary, and he obtained it. In the year 1919, during a solar eclipse, a group of scientists literally photographed the evidence of Einstein's ideas. The photographs showed that the sun's gravitational field indeed bent the light from a star passing nearby. You still remember that visual experiment with the fabric and balls of different sizes. After the solar eclipse experiment, everyone became completely convinced that Newtonian theories needed to be reconsidered. Einstein was then asked what he would have thought if the experiment had shown him to be wrong, to which he responded with his characteristic sense of humor. In that case, he would have felt sorry for God because the theory was correct. Immediately after the theory was confirmed, Einstein became a celebrity. After the First World War, Europe needed big names that could unify people, and the bright and relatively young scientist was an ideal candidate. He was featured in all leading newspapers worldwide. It was the kind of fame that today is familiar only to the top pop performers. The rise of anti-Semitic sentiments in Germany prompted a counter-reaction from Einstein himself. He began to identify as Jewish and declare it publicly. In the year 1921, he arrived in the United States. His ship was met by 10,000 people, a top level of popularity for that time. In America, Einstein first spoke not only as a scientist, but also as a public figure. The most famous scientist in the world engaged in fundraising to aid Jewish refugees, Jewish scientists, and the Hebrew University. A year later, Einstein received the well-deserved Nobel Prize. As I mentioned, it was not for the theory of relativity, but for his work on quantum theory. This is especially amusing, as around this period Einstein himself began to doubt that very quantum theory. Other scientists found more and more confirmations of his correctness, but Albert could not believe that physics could deviate so far from the classical theories of Newton and strict cause and effect relationships. Another interesting aspect of the genius's life was his belief in God. He was, of course, not religious in the traditional sense of the word. He believed that God did not create nature, God is nature. And the main proof of the divine's existence is not the presence of miracles, but their absence, that the universe follows laws. The devout genius physicist broke the mold so profoundly that Albert continued to be questioned about his religious beliefs until the end of his life. On one occasion, he responded with a beautiful metaphor comparing humanity to a small child who enters a vast library filled with books. All these books are filled with the mysteries of the universe and arranged in a specific order, and we are only beginning to read these books and understand the logic of their arrangement. Religiosity and conservatism were not the only changes that took place in Einstein during the second half of his life. He was a committed pacifist, refused to serve in the military, and opposed invasions. But with Hitler's rise to power in Germany, Albert changed his views. At that time, anti-Semitic sentiments in the country were becoming part of state policy, and in the year 1933, he emigrated to the United States with his wife Elsa, where he spent the next 20 years of his life. In America, Einstein taught and engaged in public activities. In the year 1939, he signed a letter to President Roosevelt. The authors pointed out the threat of Germany developing an atomic bomb and the need to respond proactively. 2 years later, the famous Manhattan Project for creating atomic weapons was organized, and in the year 1945, it would be used in Hiroshima. After this, Albert Einstein possibly became the world's most renowned opponent of nuclear weapons. He wrote numerous letters to politicians engaged in public speaking, advocating for arms control. Finally, he pronounced his landmark phrase that if World War III were fought with atomic bombs, the fourth would be with sticks and stones. Despite all of Einstein's pacifist efforts, in the year 1946, the famous cover of Time magazine was published, featuring the scientist against the backdrop of a nuclear mushroom cloud with his most famous formula written on it. Of course, this was unfair. Yes, the famous formula led to the discovery of the nuclear chain reaction, which in turn is a key aspect of atomic weapons. But it's hardly fair to blame a manufacturer of a sharpening tool for someone using it to sharpen a knife and commit a crime. Einstein had no involvement in the Manhattan Project. Due to his pacifist views, German citizenship, and suspicions of communist affiliations, American intelligence agencies did not allow the scientist access to classified developments. Until the end of his life in the year 1955, Einstein would be focused on two main tasks, both public and scientific. The first was to ensure peace on Earth and the non-use of nuclear weapons. The second was a grand theory that would unify classical physics, quantum, and the theory of relativity. He worked on both tasks even on his deathbed, fully aware that he would not leave the hospital. He died from an abdominal aortic aneurysm at the age of 76. Albert Einstein was and remains the most famous scientist in human history, and there are many reasons for this. Firstly, his image, disheveled hair, a rumpled suit, a pipe, and a general absent-mindedness are unique traits that imprint themselves in the public's mind. Albert's unusual habits were also remarkable, such as playing the violin throughout his life, and he did so quite well. Secondly, his public presence was notable. For a scientist, Einstein was incredibly active, often and willingly giving interviews, meeting with the main celebrities of his time, from movie stars to presidents. However, perhaps the main reason for his fame was that Einstein, more than any scientist in history, demonstrated that the process of creating scientific theories and creating works of art are very close to each other. We are not surprised by the popularity of artists, painters, and musicians. Einstein lived like an artist, allowing himself extravagant escapades, being bright and having numerous romances. Einstein created like an artist. Consider his visual experiments. After his death, Albert's brain was examined several times. Scientists attempted to find a physical basis for genius, some parts of the brain that would differ incredibly from the average person. These experiments did not achieve much success. The scientist's brain was more or less the same as that of most people. Einstein himself once said the following, "I have no special talent, I'm only passionately curious."